The alternative solution is to drop our perpendicular from A to the known length of 17. Now the problem with this solution is that it generates it splits up the known part into two unknown parts. Although they're related, they're not known how long they are. So we generate this x portion and the 17 minus x in green. Now when we do this, we now have two variables, so we need to set up what we call a system of equations. So I'm going to set the system this way. So I'm going to set up a ratio to solve for h using the 41 degrees. So I'm going to end up with h, and that's going to be equal to, using the blue triangle, is going to be the h over the x is equal to tan of 41 degrees. Okay, so there's my equality for h from the blue triangle. And then I'm going to solve for h here, and I'm going to end up with tan 41 times 8x, and working that out, so I'm just going to write that out, x times tan 41 degrees. So we have tan 41 is equal to 0.869. So I'm going to write that 0.869x is equal to that h value, the height of that triangle. And we can do the same thing from the right hand side. We're going to write this as h over, and I'm going to use that adjacent side of 17 minus x, and we're using the opposite over adjacent for the 20 degrees, so I'm going to do tan of 20 degrees and then work out tan 20, and I end up with tan 20 is it's equal to 0.3639, so I'm going to round that 364, and that's going to be multiplied. I'm going to cross multiply that with 17 minus x, and that's going to be equal to our height from the right hand side. Now we have two variables here, height and the x value, but they're the same height, so what I can do is I can write these equations equal to each other. So the 0.869x is equivalent to the height from the right hand side, which is 0.364 times 17 minus x, and then we can find out that x value. So I'm going to expand that out. So I end up with 6.187 minus 0.364x, and on the left hand side is going to be 0.869x. Okay, and then we can add those together. I can add 0.0364 to both sides. So I end up with 0.869 plus 0.364, and that's going to give me 1.233x, and that's going to be equal to 6.187. That allows me to solve for that x length. So 6.187 divided by 1.233, and I get a length of 5.017, or I'm going to round that to 0.18. Okay, so that gives me my x length in this picture. That's equal to 5.018. That makes the other side equal to this green length from here to here, that's going to be 11 point, that's going to be 982. Okay, just going to double check that. 982. Okay, so now I have those lengths. I can use those lengths and Pythagoras or trig to find the z and y value. So I'm just going to use Pythagoras at this point. So solving for the length of y squared is equal to 5.018 squared plus the h. Well, we have to solve for h still. So solving for h, I'm going to plug in the x value. The x value was 5.018. So because this is a system of equations, when I solve for one variable, I still need to solve for the other variable, h. And so the height that I get here, the h value is 0.869 times 5.018, and the h is 4.3606. I'm going to round that to 361. You don't have to keep this many decimals, but I'm just keeping this many decimals just to keep it relatively accurate. And then I can use that h value to calculate Pythagoras. So 4.361 squared. So I get the y value when I work out the Pythagoras theorem here is 5.018 squared plus 4.361 squared, and then I'm going to square root that, and I get 6.648 or 6.65. Okay, so that's the value of that far side. We can see that this total angle is going to be 119 when we add that together. And then solving for the z value, we're going to use Pythagoras from the right hand side. So z squared is equal to that bottom length of 11.982 squared plus the height, which is 4.361 squared, and then solving for z, I'm just going to put it into the Pythagoras theorem. So 11.982 squared plus 4.361 squared, and I'm going to square root that value. I get 12.750. So I'm just going to round that to 75. So there it is. I've solved for those two sides, y and z, and I've got the angle in there. Now this is an alternative solution to the first one in that we needed to use a system of equations because we had two unknown parts, the x variable and the height.